Hi guys, welcome to my YouTube channel Tech with Sarah. Hope you have enjoyed my last video, which explain about how to check the TCP dump version. Now this in this session we will actually look at how to capture the packet with the help of TCP dump, and if time permits, we'll see how to analyze the same as well. Okay, so let's start over. So But before we start, let's understand what is the TCP dump actually. Just a minute. So the TCP dump is the command line interface or the CLI tool to capture the network traffic. Apart from that, we usually use to identify any malicious activity in the network. Like if someone is trying to get inside your network and intrude into it, and do some uh, activity to create nuisance into your network, and we can literally identify the issues in the network with the help of this tool. And apart from that, what we can do is we can capture this network traffic and we can save this info in the form of PCAF file, which contains the data that has been intercepted from the interface or the network. Okay, so let's start with the actual commands. So, so in order to do that, we will have to list down list of the interfaces that are actually present in the system. So we can do that with the help of this command sudo tcp dump -d. You can see here. Sorry for this. You can just start off sudo tcp dump -d. So you can see the list of interfaces that are present in the system. So I have many because of some other projects that I'm doing. So this is ENP0S3 is the interface that I'm going to target to capture the TCP dump. Okay, so but to do that, we will start the capture from our system first. So for that, we have to ping an IP address. So we have to ping a site. So I'm pinging this google.com. Okay, after that, we can monitor the packets on a specific interface by giving a command sudo tcpdump -i and the name of the interface, which is nothing but this interface. This is ENP0S3. You will find similar kind of an interface or with the name is 0. Yeah. Okay, so I will start. So you can see here the flow of the packets. right? So, but if you want to analyze the packets, you cannot infinitely, like you cannot analyze such so many packets all at once, right? So, if you want to limit the specific number of packets, so we can do that with the help of the flag. We call it as hyphen C, and it is nothing but to count the number of packets that we want to restrict. So let's say I want to restrict it to the 5 packets. So what I will do, I will give hyphen C and the count, that is 5. So let's see what happens. Yeah, so you can see the 5 packets have been captured, right? Okay, but this information is very high level information. You can just see like what is the timestamp, what is the IP address, what is the source IP, what is the destination IP. So this arrow represents like from what is the source and what is the destination. So this is my source IP, this is the destination, and this is the type of the protocol, the echo request, the ID of the packet, the sequence number, and how many, what is the length of the packet, right? So, but I want to capture a bit more information about these packets, all 5 packets. So how I will do that? So there's an option, we call it as verbose. So V. So this will give detailed information about the packet that are getting uh, flown into the system or into the network, right? So let's see. So you can see that. So you can see here again, bit more information like type of the service, uh, time to live, the ID of the packet, the offset, the flag. So this is a don't fragment flag. It's like uh, it is not within the MTU size that has been specified. So it is kind of a don't fragments uh, flag. Then this is the type of the protocol that is being used, the length of the packet, right? So this is another option, hyphen V. So if we want to dig more into this packet, we can increase the verbose. So we can do double V, VV, 2 times VV, right? So this will give a bit more information. Okay. So the next option is, so we have seen the TCP dump for specific interface. So there's another flag, we call it as a hyphen N or hyphen NN. So what is that? So TCP dump command usually captures packets with IP and the port names by default. But I don't want to, make like my understanding a bit complex. So we have to uh, understand the output easily. So we can disable uh, these details. So we can keep the only IP addresses, right? So how can we do that? So we can do that with this particular command: sudo tcp dump hyphen I, name of the interface. Hyphen C is to restrict ourselves to a specific number of packets, and NN. So let's do that. So you can see we are only getting the information about the IP addresses, and we are not getting anything about any information about the you know uh, the domain name or the port number, right? We are just getting information about our IP details, correct? Okay. Then let's move on to the next command. That is, we can capture the packets from a specific host perspective. Let's say, so how can we do that? How do you know, like, what is the IP address of your host? So for that, I will run a command first to show you how to get the IP address of the host. So you can get it by using command ipaddr. Okay, that gives you the IP address. So you have already listed down the list of the interfaces, right? And you can get the IP address of the, the interface or the host on which from which you are sending the data towards the internet. You can get it by checking the interface name, and inet will give you the IP address of the host. So this is my IP address of the host, right? Okay, so let's fire the command which I have shown you. That is nothing but sudo, this one, sudo tcpdump -i, name of the interface, the host and the host IP address, and -c is to restrict the packet to specific number, right? So let's try that. Okay, so I'm giving that. You can see. So this is my host IP. It is moving to the another uh, like domain name, right? Here, the my host IP, the port from which it is getting out, and the name of uh, the website, right? So this is fine. So similarly, what we can do is we can capture the packets and filter it with the source IP or destination IP. Then we can capture the packets and filter it by network source IP or network destination IP to which you are targeting. And another important command that we can use to capture to save the this particular output is this command. So let's try this. Sudo. We can write the output to a specific file which we want to write. So let's say I want to capture this output of this whole command to a file. This the file type of the format is usually .pcap, that is packet capture, right? I want to give for this particular host, I would like to capture the packet, right? Okay, so just a minute. So I have given the incorrect interface, so that's why it has given me an error as it's 0. Okay, so my interface is ENP0S3, right? So this is my interface. So the TCP dump command has been started, and the the it is trying to listen on this particular interface, and packets are getting captured. Once I will you know stop capturing, then only it will stop that data. So I will do it by using command control C. Okay, so you can see 231 packets have been received by the filter. So we can see whether it has been listed or not. With the help of ls command, you can see here the capture 4.pcap. But this is not in the human readable format. So in order to read this particular PCAF file, we generally make use of uh, uh, the another tool. We call it as a Wireshark or T-Shark. So I have that installed already. So I can just give you a glimpse of how exactly this particular PCAF file usually look like. So I have to give Wireshark and name of the PCAF file. So it will open up the Wireshark tool, right? So you can see here the flow of the packets. So 10.0.2.15 is the source IP, that is my host IP, and the destination IP, that is 172.217.27.206. What is the type of the protocol used? That is the ICMP protocol. What is the length of the packet? That is 98. And the information about the ping request and the response that we have received, right? So uh, this is another different topic altogether, or tutorial we can work upon. So it contains the frame number. So it is a kind of a TCP/IP protocol that we have to dig deep into to understand this uh, by protocol, layer by layer, right? So you can see here that this is a physical layer protocol which tells us about the frame. This is a MAC, right? L2. This is layer layer 3 IPv4, right? And this is the application. Okay, so this is fine. Let's head on towards another command. So before we do this, I want to show how exactly the IP header look like. This is very important if you want to dig deep into your system or the packet. So for that, just give me a moment. So you can see here, we'll come to that point. So the IP address that we generally see is used by any particular device to connect to the internet, and it is locally or globally unique address to communicate with one another. And the IP protocol responsible for identifying the devices connected to the web. Okay, but why we need to know more about the IP header? So you can see from here the role of the IPv4 packet header. So when a computer transmits information from one device to another, they split the message into the basic communication units called as packets and datagrams. And the router forwards these packets along the IPI network until they reach the destination. So this is fine. This is theoretically fine. And the size of the packet is every packet has a maximum value of like this 65,535 bytes, which can consist of header and data. And this header can be of like length, minimum length is 20 to maximum length is 60 bytes. The role of the this particular IP header is to route, to it. This has the very important information such as the source IP address, the destination IP address, and the other fields. What are those fields? So IP header is just like a like an envelope. Like you want to send like nowadays we don't literally send much envelopes as we have uh, the mobile communication uh, or the mobile phones we use for communication. But in earlier days we used to have the envelope, right, where each envelope will contain some specific information later, right, which has the data that needs to be read by the destination, the person at the destination. So you can consider this as an example to understand this particular IPv4 header format. So how exactly that IPv4 header format look like? So it has different parameters, as I already told. So it has a version, the internet, like this internet header length, the type of the service, the total length of the packet, the identification, the flag, the fragment offset, the time to live, the protocol header checksum, the source IP address, destination IP address, and options. So let's walk over through this particular IP header in a brief. So this is like the version gives the what is exactly the IP version we are making use of. So in our case also it is IPv4. There might be IPv6 also. So what is the header length? So this header length can be, as I said already, it can be between 20 bytes to 60 bytes. So what is the type of the service that is getting used? Then what is will be the total length of the header and the data in bytes? Right? The identification, the like if it is been fragmented into different smaller pieces or not. Then the IP flag. So this whole bunch of information will be in that IP header. So the destination, can decode this particular packet and get the information that it is looking for. Okay, so let's dive deep into it by actually capturing the packet, and then we will try to decode it. So for that, I will make use of another command. So this is the command sudo tcpdump -i, the name of the interface, which you already know, that is enp0s3. Then I want to capture this header information in the hex and ASCII format so that I can decode that, right? So for that, I have to give -x. Then I want to, capture this bunch of data, uh, you know, in bytes, right? So if I want to limit this particular data to specific number of bytes, then I can mention that. If I will mention 0, then it will get whole bunch of data, total bytes, right? Then the host and the IP address of the host. Then -v once again is verbose option, which will print the information in the detail format. -w is to dump this particular packet information in this particular file, that is nothing but grafana, and this is example grafana.pcap. So I will fire this command and we'll see. For now I will not save this output because I want to show you how exactly the IP packet will look like. I want to restrict it to 5 packets, otherwise there will be a flood of information, right? So let's see. So if you can see this, so you can see here, this is the source, this is the destination, the type of protocol that is being used, the ID of the packet, then the sequence number, and the length of the packet. Okay, and this is the actual packet which we want to decode. So how we can decode? Either you can manually decode it by doing uh, text to decimal conversion, or you can simply make use of the calculator present on the internet or the decoder. So I will make use of that. So let's try that. Yes. So this is a hex to uh, decimal decoder. So I will put this information about the packet in this particular decoder. Then we can decode it. Okay. So I have copied the data. Now I will decode it. So sorry for that. So this is in the IPv4 format. So I will say yes. Okay. So you can see here our packet has been decoded. So this is the Google IP address 8.8.8.8, and it is giving me a response for my ping. Like this is my host IP address 10.0.2.15, the protocol that is ICMP, and response to my ping. So let's check, whatever we have seen in the IP header. So this is the IPv4, like a version 4. So version 4, it is being represented with this 0100. Then, this is another field, that is a differentiated service field. Then this is the byte offset. Then this is a whole bunch of the IPv4 uh, information. And we compare it with this header. You can see here the time to live. So time to live, the total length of the header, that is 84. Then identification, then the flags, the fragment offset, the time to live, the protocol that is used, that is ICMP, the header checksum, and the source IP address. So you can see 8.8.8, it is in the hex format. Then the destination IP address, right? And this is your data, actual data. Okay. So this is how you can, actually analyze your packet or decode your packet, right? Hope you have liked my video. If you like my video, please do like uh, this video and subscribe to my YouTube channel and share it with your friends. Thanks for watching. Good night.